Aloha and welcome. In this video, we're going to be talking about more application attacks. We're specifically going to be talking about cross-site and server-side request forgeries, which are known as CSRF and SSRF. So we're going to start with cross-site request forgeries. And this is a very interesting one. Have you ever gone to a website, let's say it's a banking website, and you've gone in and you've authenticated and you can look at your bank information, everything. Then you go off somewhere else. Let's say you go and look at another page, and then you want to go back to it, and you type in the name of your bank, and you go back to the page. You notice that you're still logged in. Well, the reason you're logged in is because you've authenticated, and the bank is storing a cookie, an authentication cookie on your server, or not on your server, but on your browser. So when you are next going to go back there, if it's still a valid session, if it's still continuing, if it's in that time period in which it's not going to deactivate you, then you're still able to log in. So cross-site request forgery is one where you have an attacker that is going to send you some type of, it could be a phishing email, something like that, but they're going to send you something that you can click on or inadvertently execute. And when you do, it's going to end up usually with you making a call to a website. Usually it's not going to affect your browser. It's not going to have you go in your browser and automatically do something for them. It's going to be something that's hidden in a link. Maybe it's an API call or something like that, but it's going to have you execute some kind of a call out to that site that you're authenticated to. And it's going to execute something, whether it's make a transfer, a bank transfer to them or something. This is going to happen usually in the background to keep it on the download, but this is called a cross-site request forgery. And that is a really insidious type of thing. And it's relying on the fact that you're still logged in and your credentials have been authenticated. Of course, this is a very time-sensitive thing. So if you're being attacked, you're going to have to be attacked within the time frame of you being logged into that site and authenticated. So, so it's a limited scope of use. You have to have knowledge that they're there, and you have to attack them and get it through in that period of time. But it's a very dangerous one. And then the other one that we're going to be talking about is the server side. So the server side request forgery is a little bit different. So in this case, you've got a client that's inadvertently going to be sending a request to a server that they've authenticated to previously. A server-side request forgery is going to get a server to unwittingly go and pull out information either from itself or from some kind of an internal resource that normally the attacker wouldn't have access to. So the attacker might be wanting to get something, let's say it's going to a web server. That web server has access on its network to, let's say, databases or other resources. And the server-side request forgery is one where you are tricking a server into pulling out data. And I wanted to get some specific examples of this to show you. So to that end, I went to, and this is a technique that I want you to use as well. Pull up your AI, whether it's ChatGPT, Gemini, whatever you're using, and put in a simple prompt. Put in something like, give an example of a CSRF attack. So I did that for both the CSRFs and for the server side to get, so I could give you an example, a hard example, because in our book, we don't really have good examples of that. So in the CSRF attack, it gives back an example. An example of a CSRF attack involves tricking a victim's browser, which is already authenticated to a legitimate website, into submitting an unauthorized request to that site. So the attack exploits the fact that the web browsers automatically include credentials like cookies with any request that's made to a site, even if the request was initiated by another malicious site. So the example scenario here is we're going to force a password change. And let me go ahead and share my screen here. So I'm going to share my screen. So take a look over here, up here. You'll see that the example that they give you here, I want you to look at the code here. So imagine you've got a vulnerable bank site called bank.com where a user can change their password with a simple GET request. A GET request is just, if you wanted to put this into your browser, you can put this in there. So it's pulling in the data from, it's going to be looking for this thing called new pass. So ostensibly here, this is for changing the password. You can have, this thing with, you can make that call, using this, I guess it's a REST, well, not even, but you've got this, this URL that you can call to do a change password, and you're going to send it the new pass equals whatever it is. So what the attacker is going to do, they're aware of this vulnerable URL structure, and they're going to set up a malicious site called evil.com. And on that site, they embed an innocent-looking HTML element designed to force the victim's browser to execute the sensitive request when the victim loads the page. So all you have to do is go to the page, and it's going to automatically run. And the common technique they're using is the invisible image tag. So you're going to put in this image, and in the image, they're going to have the call to the site, and they're going to call this change password function, and they're going to have new pass equals whatever they want. And just by doing that, when the victim logs in, you're going to log into bank.com, and then you now have a valid session cookie for bank.com. And then later, you're going to visit the malicious site. The attacker is going to trick you into going to their site, whether it's through a phishing email or a forum post, and they're going to trick you into going to evil.com. When you go to that page, it's going to encounter that invisible image tag, and the image tag is going to try to pull that, or it's going to try to call on that URL. So it's going to interpret that, it's going to make the call, and it automatically attaches the victim's valid session cookies to the request. So the bank server action here, it's user/change password, new pass equals pwned123. And this is where the problem is. So the result is the attacker has just changed your password to pwned123. So this is pretty wicked. And the attack works because the server trusted the credentials included in the request, which is in the cookies, but it failed to verify the origin of the request to make sure it came from the user, not from, let's say, evil.com. So I went and did the same thing for SSRF to get a nice example of that for you. And the SSRF we've got involves an attacker abusing a web application's functionality to make the application's server perform a request to an unintended location. So that unintended location could be itself, it could be another a server behind the firewall or whatever it is that you're contacting this website through. So the example scenario they give is scanning an internal network. So imagine you have a web application on example.com that allows a user to provide a URL for an image. Think of this as like, you can set up an avatar, something like that. So the application then retrieves the image that the provided URL has and displays a preview or information about it. So the vulnerability here is that, and this is what the hacker is going to take a look, and they're going to see that, oh wow, gosh, they're using this in this way. So instead of for example.com going out there and saying image preview, it's going to look at the URL that's supplied to it over here. The attacker finds that the server doesn't properly validate this part right here. So because they're not properly validating that, they can do some injection here. So the attacker knows that the application server is likely located within a private network that contains other sensitive resources, which are normally inaccessible from the public internet. So a common target is a loopback interface. So everybody has what we call the home interface. It's 127.0.0.1, or it's called localhost, either way. And that's usually where you go to do your internal management services. So what the attacker here is going to do is they're going to say, okay, well, you want us to give you the URL for the image, and you're going to, when you display that, you're going to use that to display. Well, what I'm going to do is instead of that image URL, I'm going to go ahead in there and I'm going to put the URL as being your loopback address /admin, which will get me into hopefully an admin area. So they put that in there. And when they do, when they put that in, the way this executes is the attacker action first, they're going to submit the malicious request to the vulnerable application. The server is this web application server receives the request, and as programmed, it's going to attempt to fetch the content from the provided URL. We know that URL is the loopback address for the admin endpoint here. So the server makes an HTTP request to itself at admin. And the forgery success, since this request is coming from the server itself, any internal only services or pages, like a management console that doesn't require public authentications, they're accessed. So that's going to lead to a data leak here. So the server retrieves the contents of the admin page, which might contain sensitive management links, user details, or internal application status, and sends it back to the attacker in the form of an image preview. Or it can show up as an error message. Either way, you get the information you want. So the result of this is the attacker has successfully used the public-facing server as a proxy to access a resource on the private network they should never have been able to reach directly, completely bypassing any firewalls and network segmentation designed to protect internal assets. So that's why this one is so dangerous. So you can get information out of systems that you shouldn't have access to. And that's through this server-side forgery. So anyway, that's it for this video. Please do use AI to give yourself examples if things aren't clear to you. Some of these attacks will start to sound very similar after a while. And the best thing that you can do is query Gemini to give you examples so you can help visualize what that looks like. Because sometimes the book examples are not that good. And I'm particularly not excited about the examples they gave in this section. So please do use Gemini as your AI tutor, and I will see you in the next video. Aloha.